Those you are going to write test on tomorrow, this video will be very much helpful to you. This is the complete analysis of Jan 22 shift 1 and 2. So I have picked some questions and let's do it. Let's quickly finish this so that you will get more time to revise and practice more on the questions. Arrange the given metal ions in number of increasing order of unpaired electrons. So unpaired electrons, Mn3 plus, which will have 3d4 configuration, right? Cr3 plus, which will have 3d5 4s1. So after losing 3 electrons, that will be gain 3d3 configuration. Fe3 plus, that is 3d5 configuration. CO3 plus, cobalt. After argon, 3d6 configuration. So they are asking unpaired electrons in low spin complex. Low spin means the unpaired electrons are less, right? So here I have 1, 2, 3 and 4, right? And in T2G level or T2G levels, and chromium 3 plus, that is also 1, 2, 3, and this will become 1, 2, 3, 4 and 5, and this will become 1, 2, 3, 4, 5 and 6. So totally how we can write it? The answer becomes cobalt 3 plus will have the least, then comes Fe, then comes manganese 3 plus, and then chromium 3 plus. Okay. Then match the following and choose the correct option, which is the Fehling solution, Clemmensen reduction, Tollens reagent, Wolff-Kirchner. This you can do it fitafit, right? So AgE ammonium complex, which is Tollens reagent, zinc amalgam, that is Clemmensen, and hydrazine KOH, Wolff-Kirchner, and Fehling solution is copper sulfate. Right, then the next one, find the energy to excite an electron from first Bohr orbit of hydrogen to second Bohr orbit. So first Bohr orbit, which is minus 3.4, and the second Bohr orbit, which is minus 13.6. So what is the difference? What is the energy difference? Which is 10.2. Right, so very simple question. Sucrose is dextrorotatory, and upon hydrolysis it becomes levorotatory. And sucrose on hydrolysis gives glucose, and fructose such that levo-rotation of glucose is more than the dextro-rotation of fructose. So which of the statements are right? Statement 1 is right because the inversion of sugar happens over there. And what about statement 2? Glucose in dextrorotatory, that is plus 52.5, correct, and fructose in case of levorotatory, that is 92 degrees. So the statement reverse, that is, it should say levo-rotation of fructose is more than the dextrorotation of glucose. So which makes this as a wrong statement. Which of the following is the correct order of reactivity of given nucleophiles when treated with CH3Br in methanol? So methanol, that is a protic solvent, right? So smaller nucleophiles are more solvated. So nucleophilicity order follows in the way, first comes the larger atoms, then smaller. Okay, so which is larger? Iodine, that's larger. Then C2H5O minus, that is a strong base and a good nucleophile. C2H5O minus, then comes fluorine, then comes C6H5O minus. Because C6H5O minus, that is resonance stabilized, that will be least nucleophilic. Then this question, the reactivity on the basis of SN1. So SN1 means it prefers tertiary, secondary and primary. Not only that, here we have bridging compounds too. So here you see resonance effects peaks over there, and this side I have tertiary complex. tertiary carbocation, right, after losing Br. Then here, after losing Br, the plus charge will be produced over there. Here also the same thing, the plus charge will be produced over the bridge head position. But here you see, I have the bridge like this. I have more space. But here I have only one CH2, so which will lead to the less space over there. Right? So that makes the difference in SN1 reactivity. So triphenyl methyl cation, that comes first, and then tertiary, first and two which will be more. The first will have more space on the bridge, so there is less repulsion, and comes second. Second will be the least. Then given below are the two statements. HX bond length is higher in HCl than HF. And the statement 2 says the lowest boiling point in hydrate of group 15 element having the covalency 4. So as you see, HF bond length, that is approximately 92 picometer, right? And HCl bond length, that is 127 picometer. So which makes in HX bond length higher in Cl than HF, that is true. Then the second statement, lowest boiling point in hydrate of group 15. So in group 15, nitrogen, phosphorus, arsenic, antimony, bismuth, ammonia has the highest boiling point because of the hydrogen bonding it can produce. So other elements like BH3, phosphine, will have a lowest boiling point among them, and phosphine has the covalency of 3, not 2. The lowest boiling point in hydrate is phosphine, and that is having a covalency 3, not 4, so which makes this as an incorrect statement. Then a compound A with a molecular formula C9H11NO reacts with Br2NaOH. What is this reagent? We know this, right? To give X on treatment with NaNO2 dilute HCl to give compound Y. Y treated with copper cyanide followed by hydrolysis, it gives Z. The compound A on hydrolysis also will give compound Z. Okay. So Z must be in carboxylic acid because cyanide has been formed and it is forming carboxylic acid. From there we can go reverse about it. Hoffman bromide degradation, correct? So where I have CONH2 amide to give a primary amine. That primary amine should react with NaNO2 and HCN. So this must be in diazonium salt. Correct. Y must be in diazonium salt. So diazonium salt who will give? It will given by the aromatic compounds, not an aliphatic one. Let's try with this. If I have CONH2 become NH2 and this becomes a diazonium salt of Y. Y is treated with CuCN, so which will give you CN. So that on hydrolysis gives COOH. So if I'm taking this, that on hydrolysis also, this will produce COOH. Correct. So answer should be probably C. C9H11. Check with the molecular formula once. Which of the following statement is correct regarding the nature of the directive influence of N42 group in the nitration of benzene? I already told you electron withdrawing group like nitro, cyano or aldehydes, ketones, those will direct the incoming electrophile to meta positions. And electron donating groups like methyl group or OH groups or R group generally and NH2 groups, these are directs to orthopara position. These will activate, these will deactivate. But halogens are the one which will deactivate the ring but directs to orthopora positions. So this we do exactly in the mock test, right? It is an activating group. No. This is a deactivating group orthopara director. No. This is an deactivating group and meta director. That's true. Right. Very simple question. And C6H5NH2 NaNO2 HCl, diazonium salt, H3PO2, it will form benzene. Benzene with this C6H5 Br will be formed. Simple question. Statement 1. Orthopara nitrophenol can be differentiated by steam distillation. This question is from separation techniques. Right. So orthonitrophenol is a steam volatile which will have an intramolecular hydrogen bonding inner, and paranitrophenol it's not having any it's having an intermolecular hydrogen bonding. It's not having intra. So this can be differentiated by steam distillation. So this is true. And statement 2 says glycerol is separated from splint dye by distillation under the reduced pressure. Glycerol has a high boiling point. So vacuum distillation is used. That is also right. Under reduced pressure, right? And chromatography separation based on the differential affinities of the compound for a stationary phase. This is also true. From mobile phase to stationary phase, this chromatography happens. And aniline is commonly separated from the mixture by mixture of water by crystallization. That is false because aniline is a liquid at room temperature and is separated by the steam distillation, not by crystallization. Okay. Then KH is constant with change in concentration of gas till the solution is dilute at given temperature. So KH, Henry's law constant, it's depend on only temperature and not nature of the gas and not on the concentration also. So this is true. It will not change. Then statement 2, according to Henry's law, the partial pressure of the gas in vapor phase is inversely proportional to the mole fraction of the solution. It's directly proportional, right? So which is KH chi. So which is the wrong statement. Consider the first order reaction. A gives product. 3 different solutions are taken. Rate of the reaction, solution 1 is R1 and solution 2 is R2, solution 3 is R3. The correct order of rate of the reaction. So we know that R is equal to K of A because first order, right? So it depends on the concentration, not the volume. So we can neglect the volume. So R1 that is equal to K into 10 molar. Similarly, if I write R2 that is also 10. R3 that is K into 5 molar of A and 100 ml water. So the volumes are same. So which is half of that. So which becomes 5 molar. So the new concentration that will become 5 molar now. So the relation comparing the rates, R1 that is equal to R2 which is R2 and these are all greater than R3. Okay, the next one, the incorrect statement. P is less reactive, this is P. P is less reactive than benzyl chloride towards nucleophilic substitution reaction. So this is true. Chlorobenzene has CCl bond, right? Partial double bond character is there. So which is less reactive towards nucleophilic substitution reaction. We need high pressure and temperature conditions to do that. So this is true. And in P, CCl bond has partial double bond character. That is true. Cl is an orthopara directing group towards an electrophilic aromatic substitution. That is also true statement. This is deactivating but orthopara directing. P can undergo nucleophilic substitution reaction at normal condition. That is false. As I told you, I need special conditions like high temperature and pressure conditions, like Dow's process. The correct order of electron gain enthalpy for group 16 elements. So here I have tellurium, selenium, sulfur and oxygen. So which should be the correct order? The electron gained enthalpy generally decreases down the group, right? But we have an exception over here. Oxygen has less negative electron gain enthalpy than sulfur because of the smaller size of oxygen. We know that, right? Electron repulsion will be there due to the smaller size. So oxygen has less negative electron gain enthalpy than sulfur. So the order will be sulfur, selenium, tellurium, and oxygen. Sulfur will have around 200 kilojoules. 100 gram 98% by weight of sulfuric acid is mixed with 100 grams of 49% by weight of sulfuric acid. The mole fraction of sulfuric acid is. How much simple question they have asked. So first 98%, so 98 grams of 100 ml plus 2 grams we can take it as in water. So overall the number of moles, this will become 1 mole, correct? Sulfuric acid molar mass is 98. And for water 2 by 18, that is 0.11. The second solution if I take 49, so how many moles? That would be 49 divided by 98.5 mole plus water which is 51 by 18, that is 2.8. Now we have to calculate the total moles, which is sulfuric acid will be 1.5 moles of sulfuric acid is 1.5, and H2O that we have, that is 0.11 plus 2.8, it is 2.9, right? 1.5 plus 2.9 totally, that is 4.44, correct? Now what you can do is just they are asking mole fraction of sulfuric acid only. So moles 1.5 divided by 4.4, that would be approximately 0.33. That is your answer. Okay. Then correct order of ionization enthalpy. So ionization enthalpy is how much energy is required to remove an electron from a gaseous atom, right? For anions, how that will work? The energy to remove an electron from a negative ion, we are going to make it as a neutral atom. So removing an electron from an anion requires less energy. For anion, that would be less energy needed than from the neutral atom. Okay, so here I have F minus and Cl minus. Fluorine, that we know that will have highest electron ionization enthalpy. So that is neutral also. So I'm taking fluorine, then comes chlorine, then we have Cl minus and F minus. Okay. Then this one PHCOCl, what it will do? It will form with, in the presence of pyridine, it will give you CO. So this will take up the hydrogen and remaining I'll be having NH. CH2 C6H5 with lithium aluminum hydride, it gives Y. So CH2 C double bond O, that will become CH2. So which is C6H5 CH2 NH CH2 pH. That's your answer. This part will get reduced over there. Then which of the following is a mixed oxide? Straightforward question. This we know, which is Pb3O4. Mixed oxide means what? The compound containing the metal in two different oxidation states. Right. So first one, iron is having +3 oxidation state. Here lead is having +4 oxidation state. But this red lead, which is having combined state, 2+ also, 4+ also. Right. And barium, here that is having, this is barium peroxide. So that is not a mixed oxide. Which of the following is in basic buffer? So which will be basic buffer? NaOH with sodium acetate, NaOH with sodium sulfate, potassium sulfate with sulfuric acid, ammonium hydroxide with ammonium chloride. Basic buffer means what? Weak base plus its salt. Correct? For example, weak base I am taking ammonium hydroxide. The salt will be ammonium chloride. So this is not a weak base, that is having a strong base over there, NaOH. And this is having a strong acid over there, not a basic buffer. And option D, that's your right answer. Volume ratio of decimolar ammonium hydroxide and decimolar HCl to give a solution of pH 9.25 at 25 degrees Celsius is X:1. Find X. Okay, so this is kind of a moderate level question where I have decimolar solution of ammonium hydroxide, that is X ml. That we are taking it as X ml. And volume of HCl, that is equal to 1 ml. So moles of ammonium hydroxide initially, that would be 0.1x decimolar solution, so 0.1x. After the reaction, it will form ammonium chloride will be formed, right? So it will give ammonium chloride, that will be 0.1 moles. So ammonium hydroxide remaining would be 0.1 x minus 0.1, correct? So which is equal to 0.1 x minus 1. Let's use the formula. POH is equal to pKb plus log of salt by base. So pH is given as 9.25 and POH, that would be 4.75, correct? And pKb value is given as 4.75 plus log of ammonium chloride and by ammonium hydroxide. So that is in both are decimolar solution, that will be forming in that value will become 1, correct? So that's also 0.1, this is also 0.1, the produced will be 0.1, so that will be 1. If I am taking this value as 1, ammonium chloride concentration by ammonium hydroxide concentration, if that value is equal to 1, what we know, that is ammonium chloride formed is 0.1 and ammonium hydroxide remaining would be 0.1 x minus 1. So now what would be the x now? So just calculate the x you will get it as 2. So 2 is your answer. So overall going to write the test tomorrow. Please thorough with the basic concepts. See, in both the shift question paper, they have tested your basics only. But these physical chemistry questions, they are a bit lengthy. You can concentrate on that too. Please don't be lethargic since I'm saying the basic. The question can be asked. Prepare well, do calmly. All the best for you guys. If you need more shifts paper, let me know in the comments.